Module 1, Lesson 6, Solving Problems by Finding Equivalent Ratios. So this is a continuation of what we started in Lesson 5, using equivalent ratios as a problem-solving technique. And we are going to be heavy in the use of tape diagrams again so we can see what's happening. Learning targets, I can make comparisons with and within wholes, part to whole, whole to part, using ratio language and symbols. Obviously, when we are creating our tape diagrams, we're going to need to be able to do that. We are not looking at unit rate right now, but we are going to be making comparisons, and we're going to be figuring out what happens if part of the comparison changes, which is, of course, the whole equivalent ratio thing. I can reason about ratios and make predictions about what would happen if part of the ratio changes. I can statements for this lesson. I can use tape diagrams to solve problems when given a ratio between two quantities. And on top of that, we're going to have some before and after stuff. We're going to have some changes that occur. So the number of parts in the diagram are going to remain the same, but how they're distributed, how they're split up is going to change, and so that will change some of our answers. Now, layered in this is the importance of the C value. We're looking at the constant. When we talk about equivalent ratios, we are looking at the constant. So we're going to be using that as part of our strategy here. And of course, tape diagrams are meant to help us see that constant value. All right, so exercise 1 here, a lot of slides that go with this one. I'm going to walk through this in great detail, and then the rest of the exercises will go a little bit faster. So the Business Direct Hotel caters or serves people who travel for different types of business trips. On Saturday night, there is not a lot of business travel. In other words, people traveling for their company. So the ratio of the number of occupied rooms to the number of unoccupied rooms is 2 to 5. And we see here we've got occupied and unoccupied. However, on Sunday night, the ratio of the number of occupied rooms to the number of unoccupied rooms, so we're back to occupied and unoccupied, is 6 to 1. So here we are talking about, we still have 7 parts. 2 plus 5 is 7, 6 plus 1 is 7. So we have 7 units in our ratio, but how they are split up has changed. And this change happens due to the number of business people attending a large conference in the area. If the Business Direct Hotel has 432 occupied rooms on Saturday night, how many unoccupied rooms does it have on Saturday night? So we're going to use the information about Sunday night to figure out information about Saturday night. So we're going to use information from this 6 to 1 ratio on Sunday to answer questions about this 2 to 5 ratio on Saturday. Now, I've already pointed this out, but how many total sections will our tape diagram have? Well, we are going to have 7 sections. We're going to have 7 sections for Saturday. We're going to have 7 sections for Sunday, which is important that we understand that we have the same number of units both times. So in other words, how many equal parts in the ratio? 7. For Saturday, how will the total sections, our units, be split between occupied and unoccupied? In other words, what would our tape diagram look like? And of course, this would be a moment to pause the video and actually think about that, maybe even sketch your tape diagram. So what are we going to draw for the occupied? What are we going to draw for the unoccupied? This would be a great moment. Go ahead and pause that. What would you draw? Well, hopefully for Saturday you said, well, the ratio is 2 to 5. I'm going to erase all my marks here because the text size has changed. Hopefully for Saturday you said the ratio is 2 to 5, occupied and unoccupied, and we have 2, and we have 5. Hopefully you have something like that drawn. And then for Sunday, so in other words, let's draw a tape diagram for Sunday. How are the units going to be divided? So take a moment, pause the video, draw your tape diagram for Sunday. And hopefully you have something that looks a bit like that. So we have our ratio of 6 here to 1 here. It's important that we recognize that we still have 7 units in our ratio. Now, what is the total number of occupied rooms on Sunday night? So we need to go back in the problem, need to do a little bit of reading here. It says, if the Business Direct Hotel has 432 occupied rooms on Sunday night. So now we have a piece of information that we can actually assign to our tape diagram. We can say that these occupied rooms are equal to 432. Now in your head, you're probably thinking, ooh, I know what to do now. So go ahead and pause, do what you think you need to do, and then unpause the video and follow along. See if your prediction works out. So if there are 432 occupied rooms on Sunday night, what is the value of each of our units? How much is each unit equal to if we have a total of 432? And hopefully your brain's like, oh, I need to take 432 and I need to divide it by 6. 432 divided by 6. And find out that each one of our units is equal to 72. Now, if these units are equal to 72, what is this unit equal to? Well, haven't we emphasized over and over again that all our units will be the same? This is our constant value. It doesn't change. So the unoccupied rooms on Sunday night is 72. Now at this point you should be thinking to yourself, hey, I think I know what to do with Saturday. Now, an important question to ask yourself here, does the number of rooms change from Saturday to Sunday? On Sunday, are there 432 rooms, but on Saturday there were only 300 rooms? In a hotel, the number of rooms doesn't change. It's the same number of rooms. Is the number of rooms constant? Oh, constant. This 72 here is constant. So if this 72 is a constant, if there's 432 rooms in the hotel on Saturday night and on Sunday night, what is the value of each of the units for Saturday? The number of hotel rooms is constant, doesn't change. If there are 504 rooms right here on Sunday, how many rooms are there on Saturday? Well, there would still be 504 rooms, right? If the 504 rooms is split into 7 pieces on Sunday, if we have 7 units, how many units would we have on Saturday? According to our ratio, 2 to 5, right? Our units are going to remain the same. So each of our units for Saturday night is going to be 72. The value of each section is 72 because we have 7 parts here, 7 parts here, 7 units on Sunday, 7 units on Saturday. We are going to have the same value for each of the units. So, how many unoccupied rooms on Saturday night? Well, 72 times 5. They have 360 unoccupied rooms on Saturday night. All right, so that was a really quick walkthrough for exercise 1. And now instead of having this spread out over, 10 or 15 slides or whatever, let's just work through a problem. So here's exercise 2. Peter is trying to work out by completing sit-ups and push-ups in order to gain muscle mass. He's exercising. Originally, meaning when he started, Peter was completing 5 sit-ups for every 3 push-ups. Boy, my brain just screamed at me, there's a ratio. But then he injured his shoulder. After the injury, Peter completed the same number of repetition over and over again, as he did before his injury. But he completed 7 sit-ups for every 1 push-up. Now, it's important that we recognize here that this is 7 and 1, so he's got 8 reps. He's got 5 and he's got 3. He's still got 8 reps. That hasn't changed. We have a total of 8 units in both of these ratios. And right now my brain is screaming at me, that means they will have the same C value. During a training session after his injury, Peter completed 8 push-ups. How many push-ups was Peter completing before his injury? So we have a change happening here. We've got some ratios. So thinking back to exercise 1, let's go ahead and tape diagram the before and the after and then use the information we've got here. So I'm going to have a before the injury. I'm going to have an after the injury. My ratio before the injury is 5 to 3. And I've got sit-ups to push-ups. After the injury, I've got 7 sit-ups. And we are at 1 push-up. Shoulder injury probably makes it hard to do push-ups. And I'll do a little label here, sit-ups and push-ups. Now it says during a training session after his injury, Peter completed 8 push-ups. And the question is, how many push-ups was Peter completing before his injury? Well, looking at my tape diagram, I can see that I have 1 unit for the push-ups. So the value of this 1 unit is going to be the 8 push-ups. And that means the value of all the sit-ups here is going to be 8. Now I can do a bit of math here and say that I've got 1, 2, 3, 4, 5, 6, 7. 7 times 8 is 56. So he's doing 56 sit-ups and 8 push-ups for a total of 64 reps. He's got 64 repetitions going on here. And it says here that he's completing the same number of repetitions, which means this 64 transfers over to before the injury. Before the injury, he was also doing 64 reps. And how many units are there in the before the injury? There's 1, 2, 3, 4, 5, 6, 7, 8. There's 8 units in the before the injury. So I would take 64 and I would divide it by 8 and I would find the value of each of the before units is also 8. And the question that I'm supposed to answer is, how many push-ups was Peter completing before his injury? Peter was completing 24 push-ups before his injury. So some things I want to point out before I move on to the next one here. I read the problem, identifying the ratios. I tape diagrammed each of my ratios. I read for the information that I could put into my tape diagram. I used my knowledge of ratios to find that the value of each of the units was the same. I found the total number of repetitions, and I identified that it says he's doing the same number of repetitions. So the 64 will transfer to another tape diagram. I then counted up the units in my before tape diagram and used division to find the value of each of the units. All right, exercise 3. Tom and Rob are brothers who like to make bets about the outcomes of different contests between them. Before the last bet, the ratio of the amount of Tom's money to the amount of Rob's money was 4 to 7. Ratio 4 to 7. Rob lost the latest competition, and now the ratio of the amount of Tom's money to the amount of Rob's money is 8 to 3. Okay, the ratio has changed. The situation is different. Now my brain just screamed at me that I had 11 parts and 11 parts. I still have 11 units in both of these problems. How the units are split up is now different. If Rob had $280 before the last competition, how much does Rob have now that he lost the bet? So we've got a change that's occurred, and we're trying to figure out how that translates to actual dollars here. So I've got a before, and I've got an after, and it says before the ratio was Tom's money to Rob's money, and it was 4-7. Now afterward, the ratio is 8-3. Ratio the amount of Toms to 3. Now looking at these ratios, I have this feeling that Rob lost a lot this last go around. The ratios have really changed in opposite directions here. In this before situation, it appeared that Rob was way ahead, and now looking at it, Rob is way behind. So I'm thinking that this last go around did not go well for Rob. It says Rob had $280 before the last competition. So I have to stop and ask myself, where does this $280 fit? I've got 4 different things going on the tape diagram here. And it says Rob had $280 before the last competition. So I think the $280 actually goes right there, the before the last competition. And now that I have figured out where this $280 goes, I can say, hey, this $280 is showing me that it is split into 1, 2, 3, 4, 5, 6, 7 units, and 280 divided by 7 is 40. So each of these units is worth $40. And because of my knowledge of ratios, I know that if these units are 40, these units are 40. So I had $280 for Rob here, and then I've got 40 times 4, which is $160. 280 and 160. There's $440 that's being split between these two brothers. And that transfers right over here. The amount of money has stayed the same. The value of each of the units has stayed the same. So I could take the 440 and I could divide it, and I would find that each of the parts is worth 40. And that helps me see that Rob has 40 times 3. He's now got $120. He just went down 160 bucks. That did not go well. Tom, on the other hand, hey, things are going great. He's up 160 bucks. All right, exercise 3. The sporting goods store ordered new bikes and scooters. For every 3 bikes they ordered, 4 scooters were ordered. I just keep seeing this ratio language. However, bikes were way more popular than scooters. So the store changed its next order. The new ratio of the number of bikes ordered to the number of scooters was 5-2. So if the same amount of sporting equipment was ordered, so if they ordered the same total number of bikes and scooters, and they originally ordered 64 scooters, how many bikes were ordered as part of the new order? So once again, we have a before and after. And my brain is screaming at me. 7 units, 7 units. So I've got my before situation, I've got my after situation. My before situation, I've got bikes as 3. I've got scooters as 4. In my after situation, because the bikes were way more popular, I've got 5 for the bikes, and I've got 2 for the scooters. Now it says 64 scooters were originally ordered. So in the first order, in the before order, it was 64 scooters. And right about now, my brain's screaming at me, hey, that's 64 divided by 4, and I would find out that each of the units is 16. And if each of these units is 16, that means each of these units is 16. And it says the same amount of sporting equipment was ordered both times. So I've got 64 for the scooters, and I've got 16 times 3. I've got 48 on the bikes. So I've got 48 and 64. And I find out the total amount of bikes and scooters ordered was 112. That 112 can be transferred to the after situation because it says the same amount was ordered both times. So now I've got 112, and it's divided between 1, 2, 3, 4, 5, 6, 7 parts. I've already done 112 divided by 7 parts right over here. Each of the units will be equal to 16. And it asks how many bikes were ordered as part of the new order. Well, this is my bike tape diagram, and this is my scooter tape diagram. And I've got 16 times 1, 2, 3, 4, 5. 16 times 5. And I find out that 80 bikes are part of the new order. And we're only going to get 32 scooters down here. Exercise 5. At the beginning of grade 6, the ratio of the number of advanced math students to the number of regular math students was 3 to 8. So I'm hearing another ratio. The ratio of. However, after taking placement tests, so they take a test to decide if they're in the right math class, students were moved around, changing the ratio of the number of advanced math students. The ratio of the number of advanced math students to regular math students is now 4 to 7. How many students started in regular math and advanced math if there were 92 students in advanced math after the placement test? All right, so I've got a before situation, I've got an after situation. My brain has already been screaming at me that this is 11 units and this is 11 units. The only difference is how they're organized. And we've got the advanced math and the regular math. And in the advanced math, we had 3. And in the regular math, we had 8. After the placement test, I've got 4. And I've got 7. And it says 92 students in advanced math after the placement test. So 92 goes right here. There are 92 in the advanced math after the placement test. And so this 92 is divided by 4. And I find out there were 23 for each unit. Which means there's 23 in each unit. So I could calculate the total number of students at this point. So I have my 23 times 4 that gave me 92, and I've got 23 times 1, 2, 3, 4, 5, 6, 7. 23 times 7. And I've got 161 there, and I could add them together and find out there were 252 students. And that transfers over to the before situation. But by now, most of you have probably figured out that the number of students isn't going to change between the before and after. There were 253 students after. There were 253 students before. And that means because the number of students hasn't changed, our units haven't changed because we've got 11 units on both sides. But I do like to point out to you that we can take the 253 and transfer it over to the before situation. We can count up the number of units, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. we could take 253, we could divide it by 11, and we'd find out that each unit is equal to 33. Sorry, 23. And then we can do a little bit of multiplication. 23 times 3, do some erasing here, find me a little bit of space to do some computation. 23 times 3, there are 69 in the advanced math before, and 23 times 8, 8 times 2 is 16 and 2 is 18, and there were 184 in the regular math before the placement test. Exercise 6. During first semester, the ratio of the number of students in art class to the number of students in gym class was 2 to 7. However, the art classes were really small and the gym classes were large, so the principal changed students' classes for second semester. In second semester, the ratio of the number of students in art class to the number of students in gym class was 5 to 4. If 75 students were in art class second semester, how many were in art class and gym class first semester? Once again, I notice that I have 9 total units. Now, it's possible that you will encounter problems that do not have the same number of units before and after. Maybe this one would be 3 to 7 and this one would be 5 to 4. So because the problems are nice this time, having the same number of units, don't believe that that will always be true. Always look and make sure. All right, so I've got first semester, I've got second semester. In first semester, I've got the ratio of the number of students in art class to gym class, and the ratio is 2 to 7. In second semester, I've got art class as 5, and gym class is 4. And it says there are 75 students in art class in second semester. So they've given me the value of this right here and said, hey, this will be 75. And 75 divided by 1, 2, 3, 4, 5 is 15. So each of my units will be worth 15. Which means each of these is worth 15. And we are trying to figure out how many were in art class and gym class first semester. Well, this would transfer right over here, that 15, because I have the same number of students first semester, second semester. I have the same number of units first semester, second semester. They're both 9. That 15 is going to transfer right over. Now, if somebody were to ask you how many total students there were, you know that this tape diagram is worth 75. This one is 15 times 4, which would be 60, and you would know that there are 135 students. You could then take the 135 students, and you could say that it is split into 9 parts. And we would find that each part is equal to 15. Jeanette wants to save money, but she has not been good at it in the past. The ratio of the amount of money in Jeanette's savings account to the amount of money in her checking account was 1 to 6. Because Jeanette is trying to get better at saving money, she moves some money out of her checking account and into her savings account. Now, the ratio of the amount of money in her savings account to the amount of money in her checking account is 4 to 3. If Jeanette had $936 in her checking account before moving money, how much money does Jeanette have in each account after moving money? So we have the before the move, and we have the after the move, and we have her checking account, and we have her savings account, and the amount of money in her, well, you know, I'm going to reverse it so that my tape diagrams match here. We've got the amount of money in Jeanette's savings account to the amount of money in her checking account is 1 to 6. 1 to 6. And after she moved it, we've got her savings account and her checking account with a ratio of 4 to 3. And it said she had $936 in the checking account before moving the money. So this is $936. And hopefully your brain is screaming at you, hey, I know how many units there are. 1, 2, 3, 4, 5, 6. So I can do 936 divided by 6. And find out that each unit is equal to 156. Which means this unit right here is 156. And the amount of money hasn't changed. She still has the amount of money. So after she moves it, she's still got this amount of money. The values will remain the same. If somebody were to ask you how much money Jeanette has in her checking account and in her savings account, we could total up all of these 156. So we've got 936, and we could add 156 more. And we'd find out that Jeanette has $1,192. So how much money does she have in each account after she moved it? Well, she's got 156 times 3. 3 times 5 is 15, and one more makes 16. So she's got $468 in her checking account. And in her savings account, she's got $624. All right, so what advice would you have for a friend who missed class today and needed to do the problem set? What would you tell them? I would probably tell them that, hey, you need to find the C value. The other thing I would tell them is that having a tape diagram is useful. If the problem has a ratio that changes, a good strategy is to do one tape diagram for the before and another for the after so you can see the change. And don't forget to emphasize the C value, the value of the units. So taking a look at the I can statements. I can use tape diagrams to solve problems when given a ratio between two quantities. Did a lot of tape diagramming today. I can use a before and after tape diagram to solve a problem when the two quantities change and cause the ratio to change. So I can handle situations with tape diagrams where ratios are changing. All right, so reason about comparisons. So definitely doing a lot of reasoning about ratios today. And then we are also just writing ratios and making those comparisons with proper language and symbols. All right, so that concludes Module 1, Lesson 6. So make sure you go ahead and do your problem set. If you've got questions, make sure you talk to your teacher.